everybody, I'm doing a video on week 10's Thursday assignment, which is solving integrals using partial decomposition of fractions. So our first question is an integral of x over x plus 4 times 2x minus 1 dx. And to solve that, I'm just gonna present this integral as a sum of two different integrals that are much easier to be solved. And here is what we're gonna have for the sum. For the first one, we're gonna have x plus 4 in the denominator and a on the top. For second one, we're gonna have 2x minus 1 and b in the denominator. And to solve that, I'm gonna multiply both sides with 2x minus 1 times x plus 4. So this is for one side and this is for the other side. And when we multiply, that part and this part will cancel and we're going to be left over with x. And for that part, when we multiply a over 4 plus x times x plus 4, 2x minus 1, this and this will cancel and we'll be just left with a times 2x minus 1. For the b part, this and this will cancel and we only have b times x plus 4. And to solve this, we're gonna make that part equal to 0 and that part equal to 0. So in the first case, when this is equal to 0, our x is gonna be 1/2. And we're gonna have the equation 1/2 equals a times 0 plus b times 1/2 plus 4. To solve that, 1/2 is equal to 0 plus b times 4.5, which is 9/2, or our b is gonna be 1/9. And to solve for a, we're gonna make this one equal to 0, so our x will be -4. So we're gonna have -4 equal to a times 2 times -4 minus 1 plus b times 0, or -4 equals a times 2 times -4 is -8 minus 1, -9. So our a in this case, it will be 4/9. Then we're gonna have a and b and substitute it right here. So x over x plus 4 times 2x minus 1 in our case will be a is 4/9 over x plus 4 plus b is 1/9 over 2x minus 1. And to solve the integral, we're just gonna need to take integral of that part plus an integral of that part. Okay, this is a constant, we can take it right in front, and this is a constant that we can take right up front. So what we're gonna get is 4/9 times the integral of 1 over x dx plus 1/9 integral of 1 over 2x minus 1 dx. And to solve this and this, I'm gonna use U-Substitution, which I'm gonna write right here. So this is gonna be our u, du in this case is going to be just dx. And here I'm just going to use a different letter, let's say v. That's going to be our v. dv will be 2 dx, or dx will be dv over 2. And I'm just gonna substitute all of those. Gonna have 4/9 integral of 1 over u du plus 1/9 integral 1 over v dv over 2. This is a constant that can go up in front, so this integral, just write down the 4/9. So this integral is natural log of u plus, like I said, this is going to go out, so it's going to be 1/9 times 1/2, and then this is going to be natural log of v plus the the integration constant, and then I'm just going to substitute u and v in the result. So the final answer is going to be 4/9 natural log of u, which is x plus 4, plus 1/18 natural log of 2x minus 1 plus c. So this is the answer for our question number 1. Question number 2, it will be an integral of 5x plus 1 over 2x plus 1 times x minus 1 dx, and we're gonna use the same technique of partial decomposition. So I'm just gonna copy the fraction and make it equal to the sum of two fractions. The first gonna be 2x plus 1 in the denominator and x minus 1 in the second one, and we're just gonna put our a and b. And again, to solve it, I'm gonna multiply both sides with 2x plus 1 x minus 1 on that side, and 2x plus 1 times x minus 1 on that side. So this is what we're gonna have. So right here, this and this will cancel. We'll be left only with 5x plus 1. And then on the other side, when we multiply the a part, 2x plus 1 and 2x plus 1 will cancel. So we're just gonna have a and x minus 1. And then for the b part, x minus 1 and x minus 1 will cancel, and we'll have b times 2x plus 1. And to solve that, we just need to equal this part to 0 and this part to 0 in 2 steps. First step, x minus 1 equals 0, or x equal to 1. Then we're going to have 5 times 5 is 5 plus 1 is 6 equals to a times 0 plus b times 2 times 1 is 2 plus 1 is 3. Or in this case, our b will be, let's just solve it, 6 equals, this is 0, b times 3, or b is equal to 2. And then we're gonna do the next step, that part equals to 0, so our x will be negative 1/2. So we're gonna have 5 times negative 1/2 is negative 5/2 plus 1 equals a negative 1/2 minus 1 plus b times 0. Negative 5/2 plus 1 is negative 3/2 equals a times negative 3/2, or our a in this case is 1. And we're gonna substitute right here. So 5x plus 1 over 2x plus 1 times x minus 1 will be a is 1 over 2x plus 1 plus our b was 2 over x minus 1, and then we'll just need to do this in integral form is the sum of the integral of that part plus integral of that part, and I'm just gonna rewrite it here. And to solve that, we're gonna use U-substitution again. So the first time one, this one is gonna be our u. Du would be 2 dx, or dx would be du over 2. And for here, I'm just gonna use v for this. So our integrals will be integral of 1 over u du over 2 plus, this is a constant, it can go up in front, 1 over v dv. When we solve this, this is a constant, can go up in front as 1/2. And then we're going to have natural log of u plus 2 natural log of v plus the constant of integration c, and I'm just going to substitute u in v right here and here. So the answer is going to be 1/2 natural log of 2x plus 1, which was our u, plus 2 natural log of x minus 1, which was our v, plus c. And this is for question number 2. Our question number 3 was an integral of 2 over 2x to the square, plus 3x plus 1. And we'll need to do the same thing. However, we don't know what is gonna be in the denominator. We'll need to figure that out before we can do the two integrals we need to add together. So I'm just gonna fraction this, and what I'm gonna do is just rewrite the 3x as 2x plus x, and you guys gonna see why. I'm gonna take 2x, combine those two and take 2x as a common. We're gonna have x plus 1, and then I'm just gonna rewrite this as x plus 1. So what we're gonna get is equal to 2x plus 1 times x plus 1. So our integral is gonna have the sign of 2x plus 1 times x plus 1 dx, and then from here we can just make the partial decomposition of the fractions. We're gonna do 2 over 2x plus 1 times x plus 1 equal to the sum of the two fractions. And to solve that, I'm gonna multiply again both sides with the denominator on that side and here on that side. So for this part, I'm just gonna cancel those and get 2. And for that part, this and this will cancel. We'll just have a times x plus 1 And then for the b, this and this will cancel, so I'll have b times 2x plus 1. To solve that, we're gonna make this a 0 and then this a 0. X plus 1 equals 0, x is negative 1, so we're gonna have 2 equals a times 0 plus b times 2 times negative 1 plus 1, or 2 equals, this is 0, b times negative 2 plus 1 is negative 1. So our b in this case is going to be negative 2. And if we put this equal to 0, we're going to have x equal negative 1/2. So we're going to have 2 equals a times negative 1/2 plus 1 plus b times 0. When we solve it, 2 will be equal to a times 1/2 plus 0, or our a will be 4. A and b we're going to substitute right here. So our integral is going to be dx is going to be equal to the sum of the integrals of our a is 4 over 2x plus 1 dx plus integral of b is negative 2 over x plus 1 dx. To solve those, again, we're gonna do U-substitution for the denominator. du would be 2 dx, or dx is du over 2. In here, I'm just going to use v, x plus 1, dv would be dx. And then I'm just going to rewrite our integrals. 4 is a constant. I can just put it right in front. So it's going to be 4 times 1 over u du, plus for the second part, I'm going to have negative 2 coming up in front. So it's going to be negative 2. And then the integral of 1 over v dv. And to solve the integral, this is the natural log of u minus 2 natural log of v. I'm sorry, right here was dv, like this. So this is gonna go up in front right here, plus the constant of integration c. And then our answer will be 2 times natural log. Our u was 2x plus 1 plus, minus 2 natural log of v is x plus 1 plus c. And that was our answer to solve. And we'll be using partial decomposition fraction. However, we cannot use it just yet because the power in the numerator is higher than the power in the denominator. So we need to divide those two fractions and find the remainder in order to use the partial fractions. And how do we do that? So we're gonna divide the top by the bottom. So this is our bottom. And this is our top. So how do we divide the two polynomials? What do we multiply x to the 4 to get, x to the third to get x to the fourth? That is x. because x times x to the third equals x to the fourth, and then we're gonna multiply all this by x and write it here. X times x to the third is x to the fourth minus x times x to the second is x to the third minus x times x is x squared plus x times 1 is x, and then we're gonna subtract those. X to the fourth minus x to the fourth is 0. The next power is x to the third. We don't have any right here, so minus x to the third is gonna be positive x to the third. And I'm sorry, when I rewrote, this is square here. We're gonna have minus 2 x squared minus will be plus x squared, so that will be just negative x squared. Then 4x minus x is gonna be 3x, and then our 1, we don't have any numbers here, so it's gonna be just plus 1. So we are 1 power down. What we're gonna do now is find what we multiply x to the third to get x to the third, and that is only 1. And we're just gonna multiply all of this by 1 and write it here, or technically just copy it. And then subtract one of the other. This and this will cancel. This and this will cancel. 3x minus negative x is actually 3x plus x, which is 4x. 1 minus 1 is going to cancel. So our remainder is 4x. So our first fraction is going to have that representation. I'm just copying it. So our result was x plus 1. We're just going to write it here, and then the remainder would be 4x over that part. Okay, and then we will need to do the partial fraction decomposition for this. So I'm just going to rewrite this part again. Right now we don't know what we're going to have in the denominator. We need to find the parts. So how we're going to do this? I'm just going to write it right here. I'm going to group those two and those two. So for those two, I'm going to take x squared out. It's going to be x minus 1. And when I group those two, I'm just going to take negative 1 out, and that's going to be x minus 1. I have x minus 1, and here is going to be x squared minus 1, or that's going to be x minus 1 times this one is x plus 1 times x minus 1, or if we group this and this, x minus 1 squared times x plus 1. So this is what we're going to have in our denominator. However, if we have anything to the power, when we do the partial fraction decomposition, we need to write down all the powers. So we're going to have a power of x minus 1 to the first, which is technically x minus 1, plus x minus 1 to the second power, and that's the highest power, plus 1 just for that part. And then we're just gonna write our a, b, and c on the top. And to solve that again, we're gonna multiply both sides with the denominator. So here I'm gonna multiply with that, which is the same as the denominator. And here I'm gonna do the same thing, times x minus 1 square x plus 1. So when we solved it, this part and this part will cancel, and we're gonna have only 4x equals, for the a part, this will cancel with one of those. So we're gonna have a times x minus 1 x plus 1. For b, this will cancel with this. We're gonna be only left with x plus 1 times b. And for the c part, this and this will cancel, and we'll have x minus 1 squared. And again, the easiest way to solve this is to put this equal to 0, this equal to 0, and this equal to 0. So in the first case, I'm gonna put x equal to 1. So we're gonna have 4 times 1 is 4. A times x minus 1 is 0. 1 plus 1 is 2, plus b times 1 plus 1 plus c, which is 0 square. So when we solve it, x would be this is 0, b times 2, this is 0, so from here our b would be 2. The next step, I'm gonna take x to be equal to -1, and I'm gonna have -4 equals a times -2 times 0 plus b times 0 plus c times -1, and -1 is -2 squared, or -4 would be, this is 0, this is 0, equal to c. -2 squared is 4, or our c would be -1. And then we already made this 0, and this 0. So we can pick any other value for x, and then just substitute b and c in order to find a. I'm just gonna take x to be equal to 0 because that's kind of an easy. So for x we're gonna put 0, for b we're gonna put 2, for c we're gonna put -1. So we're gonna have 4 times 0 is 0. Our a is still unknown. 0 minus 1 is -1. 0 plus 1 is 1. B is 2. 0 plus 1 is 1, plus c is actually -1 times 0 minus 1 is -1 squared. So to solve that, if 0 equals a negative times, so it's going to be -a plus 2 minus 1, or our a in this case would be 1. So right now our integral is looking like the sum of the following integrals. So right here I had this part, okay. Our a right here is 1, from this part, our b is 2. Of course, dx, x minus 1 squared dx. And our c was -1. So this is what we're gonna need to solve in order to find the integral, and I'm just gonna copy them on the next page. So we're gonna need to solve an integral of x plus 1 dx plus integral of 1 over x plus 1 dx plus integral of 2 over x plus 1 dx minus integral of 1 over x plus 1 dx, and of course this is square, and I'm sorry, this one was a minus. So this is the integrals we're gonna solve. So how is this gonna work out? Let's look at the first one. The first one we can split to two integrals, x dx and 1 dx. So this is just this, plus for that part I can do a U-substitution. For that part again U-substitution, and for that part again U-substitution. So what I'm gonna do is just gonna write it right here. So for that we're gonna take the denominator u equal to x minus 1 du would be dx. For that I'm gonna use v equal to x plus 1 dv equals to dx, and we can use v right here as well because we have the same denominator. So what I'm gonna do for the first one, I'm gonna have 1 over u du for that part, plus right here, this is a constant, can go up in front, 2 integral 1 over v square dv, which is that, minus 1 integral of 1 over v dv. Okay, and solving this should not be a problem. I'm gonna have x squared over 2 for that one, plus x for that one, plus natural log of u for that one, plus 2 times this is v to the negative 2 because it's in the denominator, plus 1 over negative 2 plus 1. This is this part minus natural log of v, and then c is our constant of integration right here. I'm just gonna rewrite those. Our u was x minus 1, and right here I'm just gonna write this a little bit better, so that is v to the negative 1 over negative 1 minus natural log of v plus c, and I'm just gonna substitute the v's on the next line. So that negative can go right here, and then v to the negative 1 is just 1 over v, and in our case v was x plus 1 minus natural log of x plus 1 plus c. And this is what the solution for our integral should look like. Thank you. I hope this is helping you.